Hey there. Today, we're going to pull back the curtain on something that, honestly, runs just about everything. I'm talking about your thermostat, rockets that land themselves, all of it. This is the hidden science of control theory.
But to get started, let me ask you something. Have you ever tried to balance, say, a broomstick on your hand? Just standing it upright on your palm?
If you've done that, then guess what? You've already dabbled in control theory. Seriously, that little balancing act, it's the perfect way to understand the big idea we're diving into. So yeah, let's stick with that, the art of just staying balanced. Because think about it for a second. You're not just holding it still, right? No way. Your eyes are locked on it, your brain's predicting which way it's going to fall, and your hand is making all these tiny, super fast corrections to stop it. It's a constant subconscious dance. So there's a name for the science of constant correction, right? Well, that brings us right to the heart of it. What exactly is control theory? At its core, control theory is the science of making systems, any system really, behave the way you want them to. And the magic ingredient, the absolute game changer in all of this, is one little word: feedback. Okay, so how does this whole feedback thing actually work? It all boils down to this really elegant, simple cycle. We call it the feedback loop. Let's go back to the broomstick. First, your eyes, they're the sensor. See the stick start to tilt. That's step one, sense. Then your brain, that's the controller, compares where the stick is to where you want it to be, which is perfectly upright. It spots the error. That's steps 2 and 3, compare and correct. And finally, your brain sends a command to your hand, the actuator, telling it exactly how to move to fix the problem. And that's step 4, act.
And that's the whole shebang. Sense, compare, correct, act. That simple 4-step loop is the engine driving pretty much every single modern control system out there. It's so simple, but so incredibly powerful. Okay, so how do we get from a wobbly broomstick to, running the entire modern world? Well, to make that leap, we've got to understand a really important difference between two types of systems. All right, check this out. It's open loop versus closed loop. An open loop system is, well, it's kind of dumb. Think of a cheap toaster. You set the timer, it heats for 2 minutes, and that's it. It has no clue if your toast is perfect or a burnt hockey puck. Now, a closed-loop system is smart. That's your thermostat. It's constantly sensing the room temperature, comparing it to the temperature you set, and then acting, turning the heat on or off to get it just right. The key difference here is feedback. A closed-loop system is basically aware of what's going on. It can see what's happening, and it can adapt. And that ability to adapt, that's everything. And once that clicks, you start seeing these feedback loops absolutely everywhere, running the show in all sorts of technologies, from the super simple to the mind-bogglingly complex. Think about cruise control in your car. It's a perfect example. A sensor feels the car slowing down on a hill. The computer compares your current speed to the speeds you set, finds the error, and tells the engine to act. Give it a bit more gas. Simple feedback loop. Now let's scale that idea way, way up. Think about a self-landing rocket. You've got thousands of sensors screaming data about altitude, speed, and angle back to the flight computers. Those computers are constantly comparing that data to the perfect landing path, and the actuators, in this case the engine thrusters, are firing thousands of times a second, making tiny corrections. It's the same loop, just on an epic scale. It even keeps our whole society running. The global power grid is one giant control system. It's always sensing how much electricity we're all using, and it tells power plants to ramp up or down in real time to match that demand perfectly. It's the only thing preventing constant blackouts. So yeah, it's the invisible engine driving everything. Modern robotics, chemical manufacturing, space exploration, even medical devices like an insulin pump that acts like an artificial pancreas. It's even at the heart of the global economy. So where does this all leave us? What's the big picture here when we think about the future? Here's the main takeaway. Control theory isn't some dusty corner of engineering. It is the absolute foundation of all automation. It's what allows a machine to work by itself. It's the logic that lets a system chase a goal, deal with surprises, and fix its own errors, all without a human having to step in every 2 seconds. It's what makes autonomy possible. And that leads to a final, really important question. As these control systems get faster, smarter, and more woven into our daily lives, what's the one thing, the one decision that we should never, ever hand over to a machine?